we now get to the literature survey point. So we discussed many steps in starting an academic research. One of the steps that is very important and is a precursor for doing your research is to perform a background literature survey. So a background literature survey is uh, studying the related papers and books and research works to your title, to your research topic. So you need to go search various um, sources that we will discuss shortly and talk about the sources that have a number of papers, like the sources that index and provide papers that have been previously published and cover uh, part or uh, full your research title. Okay, so in other words, you need to go search papers that are related to your work, that are um, covering uh, part of your research or your complete research topic. They're completely related. They sometimes you find papers that do the same method or a method that is very close to the method that you propose. So you need to do a complete survey in um, the of the papers that are stored and are indexed in international sources. Now we're gonna discuss this action, the literature survey, which is very important for everyone who wants to start a research project. The important part of the literature survey is that you uh, need to do a comprehensive search. Means that you need to search, you need to cover all the sources that may that may have published or may have stored and indexed any paper that could be related to your work. This makes it a significant part of your research, as important as the research itself, because this is the only reliable method to show and to reveal and to indicate the position of your idea with respect to existing work. In other words, if you don't find the works of other people that falls fits in the area of your own research, you cannot find where you stand um, with respect to others, and you cannot highlight your research significance, because if you don't show that others what others have done, the examiners will look at your work skeptically, and they will criticize your work as something that has not been compared to others. So this will raise skepticism to your intentions and to your work, because they say, okay, you are hiding something. Therefore, this is very important from this point. From other points of view, for example, becoming familiar with different um, successful attempts on solving the problem that you are presenting. Maybe you are solving a problem that has multiple aspects. Some people worked at it and looked at it from one point of view, you looked at it from a different point of view. Looking at people's work and their research results and their research achievements will enlighten you and will give you insights into all possible ways of solving the problem. and whether they were successful or not successful. And if they were not successful, what was the reason? If they were successful, what was the reason? Even you can use one of those literature survey papers as your base work and then build up incrementally on top of it. So you provide a new idea that completes the idea presented in that paper. So, so this is a very important step. This course, the seminar course, is intended to make you familiar with how to do literature survey and where to search for papers, especially this session. So these are the main objectives of a literature survey. Number one is identifying key research works and works from famous researchers in the area. Number two, summarizing theoretical foundations and evolutions in the area. So, in other words, uh, by doing a literature survey, you will find any theories that are related to the ideas and to the problem and to the area of work that you were working on. Number three, you will demonstrate your own efforts and your study work and ensure that your work and your idea is novel. By novel, what I mean, it's new, it has contributions. And then this way you will highlight the contributions of your work with respect to the existing work and the capacity to transcribe survey papers. So, what is a survey paper? A survey paper is a paper that actually does a literature survey in a particular area. Say, for example, you want to work in uh, blockchain technology. So, the blockchain technology is a hot area of research. So, there's so many papers being published there. By reading papers in the area of blockchain, you become potentially able to actually write a new paper that surveys all those papers that you wrote. But for us, as early researchers and as first step researchers, you're not required to publish a survey paper. You're required to only do a literature survey in your own area, and so you need to summarize the papers that you download and make sure that you make up your mind and know what others have done. Okay, what kind of literature, what kind of published work is really worth reading? What should we read? What should mm, we avoid? Of course, uh, one of the most uh, reliable and important I apologize. Sorry. My network was disconnected. Sorry. Today I don't have a good network connection, so that's why I get disconnected. Okay, so reference books are the books that are the main books in a particular area. They are used by scientists. They are written by famous scientists and or by a group of scientists, and they are used to uh, provide a reference to the main concepts of an area. Textbooks. Textbooks are the books that are being taught in the university for a course, for a particular course. So textbooks are also good references. And the standards. What are the standards? Standards are those that are uh, published to show the details of a particular standard. For example, when we talk about uh, email, when we talk about a protocol such as email or HTTP or other protocols, each protocol is a standard. So the documents that describe the details of like internet protocol called the RFCs. Um, you know RFCs? Request for comments are one type of standards that describe a network protocol. Okay, another set of uh, references are articles or papers. The papers are from peer-reviewed journals and conferences. So what is peer-reviewed? By peer review means a paper that has been reviewed by some examiners. Sometimes papers are not reviewed and they're published online. But papers that are uh, peer reviewed are very reliable because one, two, or even sometimes three referees or examiners have looked at them and made sure that the papers uh, are authentic. They do not have flaws. Their text is reliable, and they're not like made up of some figure making or they're not fake. So a peer-reviewed paper, especially those published in journals, because journal papers undergo a lengthy review process. Like the review process sometimes takes months, multiple months, or even a year. And that process, multiple referees or um examiners read the paper, ask questions from the author, and make sure that the paper is authentic and reliable. So, the papers that you download from prominent journals, from famous journals or conferences, are reliable and you can use them in your literature survey. Other sources are news articles, but not all news articles. Only news articles that are citing reviewed papers. So a news article may be reliable in some sense and unreliable in other sense because news articles are usually written in a different way than a scientific paper. They are mostly uh, journalistic, uh, and their text is mostly uh, intended for general audience, for general people, not for people in the scientific area. So they may have exaggerations, they may have phrases and terms that are not scientific. Therefore, the news articles really are not the best type of references. But especially those that cite or give reference to peer-reviewed papers are useful. The following references should not be cited. So you should not use these types of references. Laboratory notes. So you work in a laboratory, you do some experiments, and you take notes on a piece of paper or in the computer. Those types of notes, because they have not been reviewed, they are not reliable. They're neither been they have neither been reviewed nor published, so they're something private. Emails, receiving email from somebody who speaks about a scientific method, that's not uh, citable. You cannot cite it. You cannot refer to somebody's opinion in an email or in an opinion survey online or in their notes. Those notes need to be published. Anything published from somebody can be referred, like published and reviewed, can be referenced. Unpublished test results cannot also can also not be used for citation. And last but not the least, Wikipedia and similar references. You cannot use Wikipedia and similar references for the purpose of uh, referring as a related literature. So, for example, if you want to review papers in the area of blockchain, you cannot go read Wikipedia uh, webpage uh, about blockchain because that's not a scientific reference. All right. Sorry, this is a book, so that was a typo. I fixed it. All right. So when you're doing a literature survey, you are trying to get a proper comprehension and understanding of the works that other people have done. Therefore, uh, reading their work, reading related papers, should not be just reading them and accept them. In other words, scientific papers are not like an articles, are not like books where you read them and you kind of maybe accept them, especially holy books, especially like very famous books. You usually accept them without thinking and without criticizing. Articles need to be fully analyzed and criticized. You need to do two things. One, detect contributions and novelty. So, what is novelty? Novelty and contribution are new things done by the paper author. So you need to find, when you are reading a paper, you need to find what new things they have done. On the other side of the coin, you also need to look for their mistakes and imperfections. Not all works are perfect. They always have flaws and mistakes. So you need to look for um, any potential mistakes in the analysis, in the tests. So sometimes you look at a paper, see they have pretty good results, very high numbers. But when you go deep into their analysis, you find out that their analysis is wrong. They are not looking at the worst case; they are looking at the best case. But looking at the best case is not acceptable in that particular problem, for example. So you realize that all those good numbers were because of a mistaken analysis, an imperfect analysis. Therefore, you put that paper aside. You do not accept it. The third thing that you need to find when reading a paper from previous work is whether it's useful for your research or not. So ask this question from yourself. Is this work useful for my research? Does it provide related methods and data? If you answer yes to these questions, then this paper is a good reference and you can keep it. If you answer no to these questions, then you should put it aside. Okay, what are the main steps when searching sources and finding relevant when doing a related work survey? The first step, step number one, is to search. Search where? Sorry, I don't get your question. What do you mean? Answer to what? Here? You mean this? This question? Well, there's no answer to it. I said when you are reading a paper, a related work paper, you need to ask these questions from yourself. When you read the paper, ask yourself whether the paper is useful for your research. Is it related to your research? Does it have any related data or methods? If you find it related and if you find that it gives you some related data and methods, then it's useful, you keep it. I don't have any answer to this. It depends on the paper. Okay, the first step is to search and find relevant papers. Search where? Search in authentic sources. What are those authentic sources? We will answer this question next. Suppose I download a paper. What do I do? First step, after downloading the paper, which is number 2, is to check the abstract and conclusion of the paper. The abstract of a paper provides you with a brief introduction and part of the results. Therefore, when reading the abstract, you can find out whether this paper is related and whether it has good results, whether it can be useful. If you don't uh, get to a decision at this point, also go to the last part of the paper, which is the conclusion, and look at the conclusions that the authors have drawn. And looking at their conclusions, you may find out what results the paper obtained. And based on those, you can tell whether the paper is related and whether the paper has significance. At this step, step number 2, we put aside some papers We throw them away. We don't need them because they're not related. They're irrelevant or less relevant, and you keep a number of papers. The first question might be, okay, how many papers do I keep from those that I searched? I don't know. You may need to do multiple searches. The first search, you may end up with 10 papers, and then from that step, you can go further and mm, find more papers and go this way uh, until you finish. Okay? All right. So once you have all the relevant papers, you need to classify them and prioritize them. So classify means that some papers might be related to a subtopic, some papers may be related to another subtopic, or maybe you classify them based on their method. For example, if you are trying to do research in the area of saving energy in cloud, then there might be multiple methods. Some methods are by controlling uh, the power source. Some methods are by controlling the downstream services, the services provided by the cloud. Some others have the uh, some other methods propose to use a hybrid way of both, uh, and then you need to prioritize them according to their relevance. The more related papers get the higher priority. So you have a bag of papers, maybe 20 papers, but first you need to go read, deeply read the papers that are more relevant. And now we get, after step 3, we get to step 4. What do we search? That's a very good question. We need to search. We need to know where is the best place to uh, search for scientific papers. The best place in general, the best general place is to use search engines, but not all search engines. Mostly scientific or academic search engines. Here we have the name and address of a few scientific search engines. Scholar, Google Scholar, Archive, which is from Cornell University, and Microsoft Academic from Microsoft. What do you get when you search in these? They will give you papers. When you search some topic, you will receive papers, keywords, project and research web pages, and so forth. So at the end of your search in a search engine, you get some papers, standards, articles. However, this may not be the end of the story. Other sources are research groups' web pages and list of important paper resources. So what is research group web pages? Sometimes you know people, researchers who work in an area such as, say, blockchain. Then instead of going and searching in Google Scholar, you directly go to their website. They look at their works and look at their success stories, read their papers directly instead of going to search engines. This gives you a shortcut, a very fast way of getting um, to the papers you want. But it also gives you a limited access because not all papers are available on their web pages. Neither you know everybody who might be famous in the area. Second, I will be back. Guys, I'm back. Sorry. Okay, let's get to the other sources. Publisher's digital library. Sometimes a paper is published by an institution. Um, you go directly to that institution. For example, IEEE, Institute for Electrical and Electronic Engineers. This is a very important and famous institution that publishes papers. So they are direct publishers. They publish papers from people, but their papers are indexed in their own digital library. You can also find their papers in Google Scholar, but a direct way is to use IEEE Explore.ieee.org or digitallibrary.acm from the Association of Computing Machinery or Journal Finder Elsevier.com. Other than the publisher's digital library, we also have websites from journals, like direct websites of journals, conferences, and workshops. You go directly to a particular journal and download papers. But honestly, sometimes you don't know many journals, or you don't know where your paper is, or you don't know whether this journal is reliable or it's not. Do you have my voice? Okay, because your friend. Okay, okay, all right, good. There are a number of sites or bases, such as Web of Science, Scopus, these are the two most famous ones, JCR, that are indexing papers and are giving credit, giving rank to the papers, to the journals. These sites help you to find good journals, famous journals, journals that are more reliable, journals that are more important, journals that are more prominent, and they are more used by the researchers. They publish better papers. Now, with referring to these sites, you can have a view of whether your paper, the paper that you downloaded, is a good paper or reliable paper or not. Of course, here's the thing. None of these that I already described are free. Even from IEEE or ACM, you cannot get all papers for free. Some of the papers are free if they're open access. If they're not open access, you need to pay for them, or your institution, your university needs to have a subscription. Our university provides free access to many of the papers. I will show you how. So if you need to download a paper, you can connect to the university subscription and get the papers. This is an example of one of those databases called the Scopus. The Scopus has nearly 70 million items with uh, over 5,000 from over 5,000 publishers to 22,000 journals and 150,000 books, 70,000 institutions, and 12 million others. Okay, so it's a huge database of scientific um, papers, 1.4 billion references from 1970 onward. This way you can analyze the journals, manage decide whether the journals are good or not, find collaborators, pay people who work in a particular area, and so forth. How do we know whether a journal or a paper is a good one or not? Whether a journal is reliable source or not? There are statistical indices regarding the papers and the journals, which will help us to rank them. And based on the ranking, we will uh, decide whether it's a good one or not. Depending on the countries, the disciplines that they cover, the number of papers and citations, and the relationship, the average number of citations with the paper. Before getting to these science indicators, let's do a quick search. Let's go. I'm actually going to share my uh, Okay. 1 second, I will share my screen. All right, okay. Scholar, Google Scholar is an example. Say, for example, we want to uh, quickly do a search in um, the area that we talked about, energy efficiency in data centers, which was your homework. Okay. Now, do you see my screen? Yes, I started with the Google Scholar, and then we'll see the IEEE as well. So, can you see my screen now? Anybody who is unable to see the screen? Anybody who cannot see the screen? Yeah, I need those people who cannot see. Just a slide. Oh, okay. Let me share again. How about now? Any change? Oh, okay. So I still don't see the page. If that's the case, then let me share my entire screen. How about now? You may have weak internet, but oh, okay. So by saying me too, you mean that you don't see my screen? Anybody who can see my screen, just put a plus. Those who cannot see, put a minus. Send a minus. No, just put a plus. Imran. How about others? Okay, this is very strange. Okay. Okay, so I see some of you are actually able to see it. Okay, then let's continue until we get to a point. Okay, so look at this. We searched and about 5,170,000 results have been found. Number one, energy efficiency in data centers. It's a PDF. If I open it in a new tab, it will actually give me the PDF. This is not a. This looks like a uh, technical report or a. So these are the names of the authors. This is the name of the web page for you so that you can directly download. So this cited by 55 here means that this paper has been cited by 55 other sources or other papers. If you click on it, it shows all the papers that cited this paper, and there are 55. Anyway, this number 55 shows a high number of citations, although this paper is from 2007. Here you can limit the papers by their publication year. For example, you can only show papers from 2018 or papers from 2021. So now we only see the papers that are from 2022, not even 1 year before, just this year. Look at this paper, the first one. It has been published in 2022 in the Journal of Elsevier Journal of Information Systems, and that paper has since received 19 citations. This is a very uh, this is a very outstanding looks a very outstanding work because it has received 19 citations in just 1 year. Let's open it. It takes us to the publisher's website, Science Direct. Here we have an abstract of the paper and the citations. And here we have view PDF. But the view PDF is not active. It's inactive. It says access through your institution means that you go access it through the university because this paper is not free. Or you purchase it or you click on this to pay money and get the paper. But it is not required because our institution, the university, has already paid and you just go download. So to read this paper, you need to download it from the university's website, which we will discuss next. For example, uh, we will discuss it next week probably. Anyway, so here at least you can see the abstract of the paper. Energy awareness presents an immense challenge for cloud computing infrastructures and the development of next generation data centers. Virtual machine consolidation is one technique that can be harnessed to reduce energy related costs and environmental sustainability issues of data centers. In recent times, intelligent learning approaches have proven to be effective for managing resources in cloud data centers. In this paper, we explore the application of reinforcement algorithms for the VM conservation problem, demonstrating their capacity to optimize the distribution of virtual machines across the data center for improved resource management, and so forth. So you read this. Here we have some results, and based on this, we can uh, we can decide whether we really want to keep this paper or not. Okay. So this is Google Scholar. Other sources, for example, IEEE explore.ieee.org. These are papers that are um, exclusively published by IEEE in their conferences or journals. 5 to 6 million papers are indexed here. There is a search bar right here. You can type your keywords and search. Here it will show you the papers. On the left side you can filter based on the author, title of the journal, publisher, whether it's IEEE or others related to IEEE. Any standards that are waiting or any standards that you may download related to the keywords. And the topics of the publications. Okay, and any of these papers, you may look at their abstract. Many of them have a lock, which means that the full text of the paper is not available and you need to buy it or download it from somewhere else. But if you click on them, data center energy efficiency is the title of this paper. And here's the abstract. This is a paper published in 2015 World Congress on Sustainable Technologies. And there is also some other information. But to read the paper, you need to sign in to read the paper, or otherwise see it from somewhere else, such as the university website. Other papers that you can also look at. Some of these papers are actually open access. So let's give me 1 second. Here at the top, you can ask only for open access results. As you can see here, the open access papers have an open lock beside them, which shows that this paper is not locked. You can download it. So you click on the PDF. And you will directly get the PDF. So here's the PDF. A review of data centers energy consumption and reliability model. Okay. Similarly, we have dl.acm.org, which is the digital library for the ACM. Again, you can do a search here, and then you will get the results and download the papers. Okay, sorry, it looks like my internet connection isn't that great. Okay, it's taking forever. Anyway. Any questions? If not, let's end this sharing. Okay. You can look at the Journals Finder, Elsevier, or Springer.com for these uh, sites as well to do search. Okay, now that we learned how to search, when we find the paper, it's this paper has been published in some journal, obviously. We need to find out whether that journal is a good one, and one way to find out about the quality of a journal is by looking at the uh, journal rankings. The journal rankings are done based on the essential science indicators. Some of those are being presented here. There are two important science indicators related to the citations received by a journal's papers. What do we mean by that? Suppose we have a journal, it has 5 papers in it. Each paper published on the internet, on public or by subscription of private cloud. Sorry. So when the journal is published, many people may read it, download it from the site or from somewhere, and this they cite the paper in their uh, publications, in their book or in their paper. They give reference to the paper. If we have 5 papers in our journal and every paper receives a number of citations, the more citations our papers, the 5 papers that we have in our journal, receive, it shows that our journal is a more important one because everybody is now referring to it and citing our papers. The higher the number of citations, the better the quality of the papers because other people have found it an important paper, so they give reference to it. Now looking at every single paper in our journal, every single paper gets a number of citations. Therefore, this number of citations for a journal, number of citations by a journal, is actually the number of citations received by all the papers in that journal. Here we define a criteria, a parameter called CITE score. It's calculated this way. A CITE score in any year, for example in 2015, okay? So the CITE score for a particular year, say 2015, is calculated this way. This is a fraction. Here in the numerator, we have number of citations received by Journal X in 2015 for documents published in 2012 to 2014. Say, for example, my journal has 1,000 documents published from 2012 to 2014. These journals, these papers received, say, 5,000 citations. So all the papers in the journal that were published in between 2012 to 2014 they receive 5,000 citations. The number of papers published in 2012 to 2014 were, and we had 2,000 papers. So 2,000 papers, so the CITES score for this journal will be 5,000 divided by 2,000, which is equal, this equals 22.5. So 2.5 is the CITES score for this journal. The higher this number, the better the quality of the journal. Impact factor. What is impact factor? The impact factor is another parameter similar to CITES score, but CITES score is from Scopus. So the CITES score is by Scopus. But the impact factor is from JCR, a different institution. Impact factor is similar to this, the number of so we take a 3-year window. So we get the number of I'll type it for you. Number of last year citations to articles published in the last 3-year period. Okay, so very similar to CITES score, but with a different calculation, with different database, because the database is the JCR database for the impact factor. For the CITES score, it's the Scopus database. There is another way of ranking, which is this Cimagro journal rank. This uses a ranking with weighted average, which means that if you get a citation from a higher rank journal, that gets a higher value. Say, for example, you publish a paper and the paper receives 3 citations from 3 different sources, 1 conference, 2 journals. In the CITES score and in the impact factor case, they don't care who like in which journal the paper was published. They only count the number of citations to the paper. So if you publish a paper in journal X and your paper gets three citations from three other sources, like one conference and two journals, you get the uh, score. You score three. But inside Mago Journal Rank or SJR, which ranks are calculated based on the source of the citation, they look at the quality of the papers, the journal who cited your work. If a low quality journal cites your work, then the citation from that journal receives a low coefficient, receives uh, a low weight. But a citation received from a prominent journal, from a journal with high rank, receives is calculated with a high weight, so it gets a higher citation value. This way, if you receive citations from more important papers, your citation is gets a higher credit. Anyway, so you can look at these scores to rank journals and find out whether they are good journals uh, for your research. Questions? So this is these are the two um, um, screenshots of the Web of Science search, where it gives you the number of documents and the institution name. If you don't and the citation paper. Yes. Okay, I have an assignment for you. Well, actually, we didn't discuss the quartile, did we? Oh, sorry about that. One thing was left, which is quartile. What is the quartile? Quartile is actually a way of grouping journals in four groups. So if you rank the journals like this way, from rank 1 and go down to rank whatever, could be 2000 or whatever, 797. We divide the list of journals in four groups. The first group, the highest value, the highest rank journals are called quartile 1 or Q1. The second fourth of the journals, the second group is quartile 2, the third group is quartile 3, and fourth group fourth group is quartile 4. Therefore, when you say this journal is a Q1 journal, it means that it is in the highest group of journals. If it's Q2, it's in the second group, in the second highest uh, fourth, or 25%. Assignment number 2 for your next. Find the following journals and their related ranking criteria as follows in both JCR and Scopus indexing systems. Here are the journals. Number 1, Artificial Intelligence with the International issue number ISSN is this, just to make sure you don't mix it up with other journals. Number 2, IEEE network. This is the ISSN. Number 3, IEEE micro, and number 4, Journal of Parallel Distributed Computing. Sorry, this is number 5, Journal of Advanced Scientific Research. I will do one of them right now, and then you will submit your results next week for the rest of them. Let's go search for artificial intelligence. We want to find these. CiteScore, impact factor, quartile, and the SJR. I will share my screen again. Okay, here. So what was it? Was the ISSN was 0004 3702. Okay, let's get here. It was Artificial Intelligence Journal, ISSN, this. Or maybe you go to Google. Google is probably better. Artificial Intelligence Journal. Here. Artificial Intelligence is journal from Science Direct by Elsevier. We click on it. This is the web page for the journal. What are we looking for? We're looking for the science indicators, such as CiteScore. So let's search CiteScore. Here. We find the CiteScore here. The CiteScore is 8.7. This means that on average, any paper published in this journal receives 8.7 citations from other journals. Another similar criterion or parameter is the impact factor. CiteScore is from Scopus, impact factor is from sorry. Impact factor is from the JCR, from Web of Science. Based on the calculations of Web of Science, the impact factor for this journal is 14.05, which means that this paper receives, any paper published in this journal receives on average 14 citations. There is also another site which is in Iran, impactfactor.ir. This is actually a good site which gives you very comprehensive information. You paste the ISSN of the journal. Click on I'm not a robot, and it gives you a historical curve or plot of the impact factor. So here says that the impact factor in 2019 was 6. The impact factor in 2020 was 9, and in 2021 was 14. So it has actually improved over years. What is the quartile? The quartile is Q1. Shows that it's a Q1 paper. It is a journal. It's one of the top quarter of the journals. If we divide the number of journals in 4 divisions, 4 groups, this is in the top group. Looking at Scopus, let me see what the site score is. The site score or site factor is 8.7, and the quartile is Q1. But the weighted citation value, SJR, is 1.673. So I would suggest you guys to go use this impactfactor.ir website, which brings together all the citation and all the scientific indicators, shows all of them together for you, so you can do your homework easier. So this is your homework. All right, so it's back, and this. Let me end the sharing. Do the homework for number 2, number 3, number 4, and number 5. Submit it to LMS next week, before next week, and then next week we will continue our discussions. If you don't have any questions, let's end the session. Questions?